So what does it look like? This is a screenshot of the game taken from kind of a middle, like early to middle game stage. So, and as you can see, there's kind of a lot happening here. So what we have is we have kind of the map and what's happening in the center. And then we have a text description of events at the bottom left. And we have some stats at the right and a mini map over here. And the player is what you're controlling when you play the game. They're in the center of the map. There are enemies here. These are within line of sight. These are some enemies that, from the player's perspective, this the last time you had seen them, they were in these spots, but it's a little bit darker because you don't have line of sight. So if you were to round this corner, they actually might not be in these positions. And so then there's also items scattered around the map, and these are highlighted in purple. And there's also things like, I don't have them highlighted here, but there's stairs to go up a level. There's also a teleport trap, which if you or a monster walks into it, you'll be teleported to a different place on the level. And so whenever anything happens, so the game is turn-based, but whenever anything happens, or sorry, I should say when you execute an action and then a turn goes, a bunch of things can happen. So your player has different speeds associated with their attack and their movement, and other enemies have different speeds. Some enemies are very fast, some are very slow. So while the game is turn-based and nothing happens until you enter a key press and submit an action, when it comes back to you, a lot of things could have happened. And so because of that, and this is one of the reasons, there is a text description saying everything that happened in that turn. So maybe you swung twice against the monster in front of you, but you only hit them once. Maybe 3 different monsters had attacked you in that one turn. And so you can kind of get a sense of what's happening there with the text description of events. And in the top right, we have the player stats. So like a lot of games, you have health points and you have magic points. Magic points are a resource that you use to cast spells. You have some kind of stats that you get from items and other things like defense, evasion, and shield. And then you have like strength, intelligence, and dexterity. And those affect different types of actions. So intelligence stat, if that's higher, it makes your spell casting easier. And then it also has like noise in your level. So there's a lot of detail here. So when you go in, when you load up the game, there's 4 primary modes to play Dungeon Crawlstone Soup. So what they have what they refer to as trunk, which is usually just the latest version of the game. And the reason they do this is that in some of the web browsers, when you go to play, sometimes people will play different versions of the game. They might like to play an older version because they had added or removed a feature. And so if you download it on your desktop, this is the screen you get. If you play it in the browser, you have these kind of 4 modes. And you can play the main game with a seed. So you can kind of get some replayability with similar circumstances every time. And then there are 5 tutorial levels, and these walk you through how to do movement, how to do spell casting, and things like that, how to fight monsters. And then there are what are called sprints. And so these sprints are kind of micro versions of Dungeon Crawlstone Soup. So they are not procedurally generated like the rest of the game is. They're very difficult. I actually haven't beaten one. And so I think they're kind of a nice similar way to get a feel for the game, but it's not procedurally generated, so you have that benefit. So what does it look like when you start the game? You get to pick your species and your background. So as you can see, there's a lot of choices here. There's like 25 or so choices, and each one of these are very different. You see here they're organized by simple, intermediate, and advanced. I've probably played the game a couple hundred times, and I've only won 3 times. It's a very difficult game for humans. And so there's also the background. This kind of affects what your starting items are, etc. So I'm not going to show just a short video of what it looks like when you kind of start the game. And so here I am choosing the game mode. I'm just going to go with Dungeon Crawlstone, the main one. I'm going to play as a dark elf fire elementalist. And so I see I just start in a procedural dungeon. I'm going to check my inventory. And now I start moving around and I come across a monster, a bat in the top right that's sleeping. So I'm going to check what spells I have. I'm a magic character. So I'm going to go ahead and cast a spell. Now, what this one does is it spawns these kind of like fireball things and they'll fly off to the nearest enemy. I can also tell them where to go. So then once I kill the enemy, I start exploring some more. I come across a couple other monsters. One of them starts shooting at me. And basically, I've got to start casting spells so I don't take any damage or get hit. So I killed the rat. There's now the slug coming a little towards me. I'm able to kill it on this next cast. Still got this goblin in the top right, but I'm able to kill him again with these spells. They seem to be working out for me. And then once I clear those monsters, I explore a little bit more. And as you can see, as I move through the dungeon, more of it is revealed to me. I just don't know what is there until I get to the edge of my vision. And then I see another monster. And, this is a magic character. I'm going to try to fight a character, melee without using magic. And very quickly, I start taking damage, basically. So I'm a very weak character when it comes to physical melee. And so already in a couple turns, I'm already down to 60% of my health, and these monsters are chasing me now. So, I cast my spells, etc. So it's kind of a sense of what the game looks like when you start out. And I want to talk about actions in the game. So you have you have movement, and whenever you try to move into a square that has a monster, you will attack that monster. And you can move in all north, south, east, west, but also the diagonals as well. There are magic abilities, and basically to use a special ability or to cast a spell, you have to kind of basically open up your spell menu and then choose the spell. And sometimes for spells, there are also targets. You can rest. So if you rest for a period of time, other things will happen in the dungeon. It's basically a do nothing action. Oftentimes that means you'll be healing, but monsters may come across and find you, and then you have to react to that. There's ways to interact with the dungeon. There are doors and staircases. You can pick up items, and then a lot of items have. So you find a lot of items in the game, and these have special interactions that you can do. Right? So you can eat food. You can fire certain types of weapons or throw stones. You can quaff a potion. You can read a scroll, wield items, etc. So I want to talk about sensing actions. So in Dungeon Crawl Stone Soup, everything in the game has a text description. Part of this comes out of the fact that the game started originally as the visual part of it was just all ASCII symbols that was in a terminal. And so part of what helped, I think, the player's imagination was having the text description of everything that's happening in the game. And so in Dungeon Crawl Stone Soup, if you press X, you can switch to examination mode, basically. And what will happen is you'll see this yellow cursor over a tile, and you can now, when you do movement actions, you'll move that instead of your character. So you've kind of like paused the game and you can examine things. And if you highlight over something, say this monster right here, this big menu will pop up, and it'll show you a bunch of extra information that you would not have otherwise. So you do not get this information if you don't examine this. And we learn a lot more about this monster, and especially the game makes a recommendation to us based on our stats saying this monster looks extremely dangerous, right? And also it can hit for up to 23 damage. This is a starting character, so this monster could very easily kill this. Now you can do that for monsters, but there's also this piece of armor here. We can examine that as well, and we see that it's an item that has this base armor rating of 3, has an encumbrance rating of 4, and it has some other, it has even some fun flavor text on it as well. And when you take a sensing action like this, nothing progresses in the game. No time passes. It doesn't count as any action being executed. Okay. When you kill monsters, you get experience. You have all of these skills that you need to that you want to increase, basically, that are going to help you in different ways. So a lot of these are item specific. So depending on what your main type of combat is, if you're wielding certain melee items, you're going to increase these levels, and then that affects how well you can use that item, basically. Fighting, if you level fighting, that gives you more health. There's defensive skills as well. And basically, every time you kill a monster, you get experience. That experience is automatically set to level the skill based on the aptitude you have, and you get to change the percentage that you're training these skills. Now, this is where a lot of new players often make mistakes that are not realized until thousands of turns later, because if you don't train these skills right, you basically you have very limited experience resource, and there's a cap on it. So you're not going to be able to maximize very many of these. Honestly, realistically, if you end up maxing 2 or 3 of these, that's considered pretty high. A lot of times you don't have to maximize one, but if you neglect one, you could really cause a weakness that later on, when you are getting closer to trying to end the game, you encounter a strong monster and you fail. So there's also inventory management is a big aspect of this game. You have 52 slots basically in your inventory. Some items are permanent. You can equip them or not equip them or drop them to remove them from your inventory. And then others are consumables. So there's no limit to kind of quantity, but but you can only have, basically that type of item takes up that slot, and there's many more than 52 types of items. You can see some things in yellow. These are often pretty good. Things in purple can actually cause problems a lot of the time, but they do have their specific uses where they can be life-saving. And so a lot of this game is like trying to hold on and manage these consumables that can be life-saving to help you out of a bad situation. Okay, now combat. Let's get to this. This is the main activity of the game. There's many different play styles. So as you can see here, this is a little screenshot. We have the player here. We have like kind of a little group of kobolds here, and there's some other monsters have died recently, and we've got some fire clouds here. There's many different play styles. You can play as a stealthy backstabber. A lot of monsters will be asleep, and you can kind of sneak up behind them. And if you're holding a dagger, you can often do a backstab, which is extra damage. You can like one-shot them. But usually, if you play as a stealthy backstabber, you're very weak. You have low defenses, and your whole strategy is not to make a lot of noise. So you have to be careful about any actions that generate noise. You can play almost pure melee. So I'm not going to go too much into detail, but there are god. So when you pick a starting character, for some starting characters, you can choose what god you worship, and this is a interesting flavor of the game. There's a variety of gods, and basically, as you do things that those gods like, sometimes it's killing monsters, sometimes it's just exploring the dungeon. You will earn like piety with them, and then basically they'll grant you special abilities and sometimes even gift you with items. And it's a big element to the game. So usually when people describe what character they're playing as, they'll describe it as their species, their background, and the god that they're worshiping. So then you can play as range characters, and even for magic, there's a lot of different types of magic. So there's situational. You can generate these clouds. You can generate traps. Monsters will try to avoid these. You can kind of use them to create different like spatial restrictions on the map to try and funnel enemies. There's transformation magic, and then there's summoning. So you can there's a variety of different types of monsters you can kind of have as allies, or kind of under your control if you've like summoned them. And in all of those cases, you can issue them simple commands. You can actually tell them to attack something, or to retreat, or to patrol an area. So I want to just mention here, the game is difficult, and one of the things that's difficult about it is that if you make a mistake that leads to your death, it's just over. There's no second tries, nothing. And these games are known for being hard for humans. This is something that was posted on the subreddit for Dungeon Crawlstone Soup. Basically, somebody was like, what should I do here? They're facing this kind of special, unique monster. Normally, hydras are difficult enough on their own. This is a special 27-headed hydra. And, they posted, and basically people on Reddit gave a variety of solutions. And a lot of these have different restrictions or requirements to be met. So there's an item that's a Phantom's Mirror, which someone's, they saw their inventory. They was like, you should use this. That will clone this monster. And it turns out for this monster, its clone, if they fight, it has a good chance of defeating it. But again, you have to have picked up that item, and you can go a whole game without finding that item. You could use a Scroll of Summoning. You could use a Wander Scatter Shot. If you're strong enough, if your defenses are high enough and you have a good enough weapon, then you could just attack it directly. There are some combination things people suggest. And also you can just consider, can you run away? But oftentimes running away is a mistake, and you're not gonna be able to outrun the monster, and you'll die. So let's talk about the dungeon map. So there's more than 100 levels in Dungeon Crawlstone Soup. The object of the game, you start up here in the first level of the dungeon, and then you can work your way down, and eventually down here is these last 5 levels are the Zot levels, and Zot 5 is where you find the Orb of Zot. But now to get into Zot, you have to have collected 3 runes. There are 17 possible runes in the game, and usually these are kind of at the end of certain themed levels, and they're challenging to get. So to just get 1 rune is a big accomplishment for a new player. So over here, this is the Snake or Spider Pit. This is the Swamp or Shoals. These are kind of where people get their first runes. You really need poison resistance in the Snake or Spider Pit. In the Swamp or Shoals, you have to have a way of dealing with being mesmerized by certain monsters. There are the Slime Pits. If you have a certain resistance to corrosion, if you find some items with that stat on it, you might have a chance, but this is hard. A lot of times people will avoid this slime rune and instead go for the vaults rune, which is a little bit more straightforward, except that in the last level of the vaults, when you transcend down the stairs, there are some monsters there that will lock the stairs, and then you have to fight a whole room of monsters at once. And a lot of people, if you're not expecting that, that's difficult. So, and then sometimes people even not do that one, and they'll try and do another rune. So basically, while the objective of the game is pretty clear, you have some different possibilities for selecting runes that you want to try and go get, depending on what items you found, etc. And the game is technically infinite. There are places where there's an infinite number of levels, but you don't have to visit those to complete the base game, so I'm not going to talk to them too much. Okay, so I gave you some context on what the game is, and now I'm going to talk about it as an AI challenge problem. So these are the features of Dungeon Crawlstone Soup that are relevant to AI. We've got stochastic actions and events. The most simplest example is just melee attacks. They can miss the enemy, they can hit for partial health, or they can just outright kill a monster, and now there's no longer anything at that tile. There are sensing actions that I went over before. The game is partially observable, and not only is it partially observable, it's even unknown until it's explored. Line of sight is 7 tiles in every direction. It's a procedurally generated world, so that means every time you play is unique. And it's got a complex state and action space, and I'll talk about that in more detail. And it's got permanent death, and that's really the thing. It's you make a mistake, there's significant consequences. So let's talk about the state space complexity. Basically, in a 3 rune game, remember that's kind of the minimum game. If your player is strong enough, people will often try and see how many runes they can get, go for 4 or 5. You can try and go for 15. It gets much, much harder. And that's one of the fun challenges about it. So if we're thinking about just a 3 rune game here, you're going to visit around 70,000 tiles in a 3 rune game. These are lower bound guesses. You're going to come across at least 900 different instances of items and around at least 2,000 instances of monsters. Actually, I think these numbers are going to be significantly higher. If you treat the whole game, all of these tiles and items and monsters, this is not even considering walls or other things and kind of all the possibilities, it's a huge state space. Now, do you need to be considering all of these, like this big, this many tiles every time you take an action? Probably not. But you probably want to consider multiple levels, because a lot of strategies involve, you might run from monsters on one level to take down stairs to go to another level, and you might have to bounce between stairs to different levels. So you're probably going to want to reason about 2 or 3 levels at a time. So the state space is it's not trivial. And then technically it is infinite, although I think it's not prohibitive. Okay, let's talk about the action space complexity. There are 50 types of actions that kind of have to do with movement and resting and item interactions and dungeon interaction. And then players can learn up to 21 spells. For like a magic user who's like kind of pure magic, they can learn up to 21 spells. Also, you can carry multiple types of ranged weapons. And so these spells and ranged weapons, they can have targets to any creature in line of sight. And therefore, because the player's line of sight is a 15 by 15 grid with the player in the center, there's up to 225 targets for a spell. So if we're looking at, if we can assume a player could have, reasonably up to, they have all their spells and they have some ranged weapons, they can have up to 30 types of ranged attacks. Each of those would need would have up to 225 instances of that attack. So there's a lot of possible actions to be able to execute here, up to, kind of around, 7K. Okay, so I'm going to talk about features of a good AI challenge problem. These are some of the criteria that I think good AI challenge problems need to meet. And I'm going to talk about them on this slide. So I don't know how many of you have heard that Facebook came out with basically an API to play NetHack. So NetHack is a comparable game to Dungeon Crawlstone Soup. It's also in the same genre of considered a roguelike game. It has a pretty decent complexity to it. There's a number of substantial differences, so it is not the same game as Dungeon Crawlstone Soup, but it feels similar. Currently, in both of these domains, humans are better than AI, expert humans. And Facebook just recently released their API for NetHack learning environment in the summer of 2020, just last year. And so this October, they held a challenge for NetHack where they had asked people to design agents and submit them, and they're going to announce the results at NeurIPS this year. So we will see. Maybe this will not be true in coming up here shortly. But as of right now, it's currently true that current humans are better than AI. They're both popular enough. So Dungeon Crawlstone Soup, there's a number of players that really enjoy the game. This subreddit has 10,000 I think subscribers on it, and there's a wiki and a Discord and all these things. Both of these are available now. I mean, Dungeon Crawlstone Soup. So this API is what we've been working on the last couple years, and so this is not quite as I would say complete as the NetHack learning environment. Although we have some additional goals that the NetHack learning environment doesn't have, and I'll get into that. Basically, the NetHack environment, they're really only supporting feature vector-based representations, and they're mostly, when Facebook released this paper, they pretty much just threw deep reinforcement learning at it, and they couldn't solve it with kind of some baseline deep reinforcement learning. Basically said the rewards are too sparse, among other things. And so are they being supported and maintained? Yes. So I will say that Dungeon Crawlstone Soup, the DCSS AI wrapper, it's mostly myself leading the development under this. This is an open invitation for anyone to join me or contribute. I've tried to make it easy, and I'll talk about it. If you're interested at all, I'll talk about that at the end. And there hasn't been too many publications yet in these areas. There's been some people that have made some kind of similar small pseudo domains inspired by Dungeon Crawlstone Soup or NetHack, but only very recently have people tried on the full games themselves. Okay, another reason why I think it's a good AI challenge problem, it is hard for humans. So it took me 5 minutes to just scour the Reddit and find people saying after hundreds of games or playing for years, they finally won their first game. And I can attest to this myself. And part of the reason is there's a lot of knowledge to be acquired, both strategic and just gameplay wise, that you need in order to win the game. So I want to talk about DCSS as a goal reasoning challenge problem. I think what makes a goal reasoning challenge problem is it's got to have a rich goal space. And part of what that means is I think there's got to be opportunities for multiple types of goals. I mean, achievement goals, maintenance goals, and learning goals. I think there's got to be goals over varying time horizons. So agents balancing near-term and long-term goals, and something where there are a lot of state features. Basically, a significant chunk of the state space could be desirable as a goal, not just a very specific, like only this kind of state is the only type of goal I care about. And also something where agents have to balance perhaps conflicting goals and even just more than one goal at a time. So achievement goals in Dungeon Crawlstone Soup, this is not exhaustive. Obviously, at the top, we have acquire the Orb of Zot and exit the dungeon. To do that, though, you have to obtain a rune. But here, there's a lot of choices, right? You can obtain one of the 17 runes, and depending on how your game is playing, you're probably going to have to make a choice. I don't know if you're going to be able to decide up front 100% which rune you're going to go for, because you need certain skills and strengths to get different ones. You might have achievement goals to get strong in a certain way, either finding good items and weapons or training your skills or getting your stats to a certain level. And then shorter near-term goals are more things like defeating a monster, getting an item, or even just navigating to a tile or running away from an agent or from a monster. Okay, maintenance goals. These are some of the things you kind of want to maintain as a player when you're playing the game. Obviously, your health points and magic points, you want to keep those high. If your magic points get depleted and you're a magic user and there are monsters near you, you're very often in trouble. There are things that can reduce these stats as well that are frustrating to deal with as a player. So you might have to do some special things to deal with those. And also, if you're worshiping a god, you want to be able to use their abilities and their actions. So you might want to keep this high, and you also want to maintain stealth. Now, on to knowledge and learning goals. There's a lot of knowledge that humans have to learn to play Dungeon Crawlstone Soup. And there's really two types of knowledge here that I think about. There's state transitions. So this is learning, what do players' actions do and when can you take them? There are events that just occur. So for example, if you cast a fire spell over water, or there's a fire dragon and he breathes fire at you over water, that can produce steam, and steam can damage you and other monsters. And there's also processes in the game. There's the rate at which health regenerates. There's the damage from your actions and your likelihood to hit with an action. A lot of these change over time as you get stronger. And then there's strategy. So for example, as a new player, one of the things that are terrible are bees. So for most characters, in the time that it takes you to move one tile, a bee will move 4 tiles. They often travel in groups, and they will poison you. And so you usually can't outrun bees if you're anywhere near close to them. And so that's something, whereas usually if you see one bee, you want to turn around and run as fast as possible, or even just teleport out of there, because there's going to be a couple more near it. There's strategy about which items are best to fight different monsters. Hydras have kind of a specific thing where they're weak to fire items. And then often strategy in terms of how you're fighting monsters. So I have a little video here. Let's pull this up. So this is an agent that has opened a door, and it sees this room full of monsters, and it's going to actually back up to try and fight them in the hallway. So there's some purple clouds here. You can just ignore those. But as you see, the player's just waiting for the monsters to come to it so it can fight them in the hallway one-on-one. And this is a lot safer and generally a good tactic to use than fighting monsters out in the open. Because if you're surrounded by monsters, every monster that's in an adjacent cell to you, including diagonals, can attack you. So as you can see, the player here is being successful and able to defeat some of these monsters. And now there's only 4 remaining. Yeah. So Okay, now I'm going to talk about winning Dungeon Crawl Stone Soup, some thoughts that I have on it. I really think learning is a requirement in this game. It's intractable to human author a complete accurate model. I mean, the code is there, the game engine's there. I have even avoided looking at it because it's a significant game. It's there's a lot to it. So I, really you've got to play the game and learn what's happening. So I think any AI that's going to solve DCSS, it's got to be a learning agent. Um, and people right now are throwing deep reinforcement learning at NetHack. So these kind of full, more complete roguelike games, Dungeon Crawl, Stone Soup, and NetHack, I'm really curious. Will a cognitive systems approach be better? Will a deep reinforcement learning system be better? I think we'll see. I think we'll start to see some very interesting things in the next couple of years. So when it comes to measuring performance in Dungeon Crawl Stone Soup, there's kind of the obvious metrics, which are number of wins versus attempts. How long does it take you to win the game? Does it take you 150,000 turns, or can you do it in 75,000 turns? And then, how much training data do you need to play the game? I think, and one of the things that I really want to get into with the API that we're developing and just trying to encourage AI research in these types of domains is I really want to measure exactly how much knowledge is given to the agent and the impact that this has. And if that is knowledge that a human has spent time encoding, I think it would be great if we could track how much human time is spent encoding the knowledge. This is probably wishful thinking. I don't know if it's probably unreasonable to ask grad students, other people to, I don't know, clock in and clock out as if they are encoding any knowledge or any strategy. Maybe there's easier ways to do that. But basically, I'm joking a little bit there, but what I'm really talking about is being able to track how much knowledge is given to the agent versus how much it's learning. And so this is kind of a speculative hypothesis, and maybe this is kind of generally true, and there's nothing too new about this. But I think what we expect is that if we consider here on the left, the y-axis, which is the amount of training data needed, you could think of this as the number of simulations. And then we think about the amount of domain-specific knowledge given to the agent. So the training data here on the left side, I have this going from like 10 to the 1 to 10 to the 9. The reason I put a billion here is because that's how many simulations the NetHack paper used to train some of their deep reinforcement learning baseline agents on the game. They let it run for up to 1 billion. And then for domain specific, I think of kind of the very minimum amount of domain specific knowledge is the human giving the agent a reward function. That's kind of the lower end of almost no domain specific knowledge. And then on the other end is kind of complete. You could imagine somebody encoding all the strategy and all the stuff and giving to the agent. And as you get more domain specific knowledge, hopefully you would need less training data. And I, being around cognitive systems folks and seeing some of the stuff, a lot of the AI stuff happening out there with deep reinforcement learning and other things, and looking at how much training data is needed, I often hear people just have this kind of sense of feeling that with just a little bit of knowledge, it could learn way faster. Humans really don't need so many examples. I was very clear to put domain-specific knowledge here instead of common sense knowledge. Maybe there's some common sense knowledge that could make that, a lot, reduce that. But basically, this knowledge element, I think it's important that DCSS AI wrapper measure this. And, in the case of curriculum learning, well, that's kind of a form of knowledge. You're giving it basically additional reward functions. So maybe that is dropping, this, how much training data is needed. But let's be clear that that's still some extra domain knowledge you're giving to the agent. And then strategy knowledge, it might take many forms. Okay, but what I really want to say is, can we build a cognitive architecture that can get here? So this is what's really exciting about that I'm looking forward to, is something that doesn't need very much domain-specific knowledge. Maybe it has some common sense knowledge, but maybe it has a lot of really good mechanisms and structures that can learn different types of knowledge very efficiently. So this, I think, is really the dream where, this is where I would like to see us get. So now I'm going to talk about learning as a metacognitive process. I don't think I could give an invited talk without talking about metacognition a little bit. So I have been fortunate enough to work with the MIDCA cognitive architecture that Mike Cox kind of spearheaded. This is a simplification of the cognitive loop in MIDCA. And so, you have the world, the agent perceives the world, there's some interpretation about the world. This could be situational awareness, how dangerous is the situation, other things like that. Maybe it could say, hey, there's this problem. Maybe because of this problem, I need to generate a goal. Then it evaluates kind of its current models and its current status on its goals. And then it, chooses which goals it wants to pursue, generates a plan, starts carrying out that plan, and this loop continues. And I'm going to talk about metacognition. So to be clear, cognition, really all of, I think about cognition, these are all very associated with world states. So we're perceiving the world, we're inferring some extra context about the world. We are selecting which goals, but here the goals are very much world states we want to achieve. And the plan we're planning using actions that change world states. So everything here is kind of closer to the world state, and that's what keeps it in the cognitive part. Now the metacognitive part is looking at instead of the world, it's treating the cognition as the world, basically. And it has a similar loop. Monitor is kind of what's observing the cognitive loop here. You have interpret. You may choose to pursue some goals to maybe fix anything here. I didn't mention this. One of the big things about interpret is identifying failures. And so in cognition, where there can be a lot of failures in different places, perhaps there's a failure to explain, perhaps you can't generate a plan to achieve your goals. And then also where I think metacognition can really shine is failure of cyclic behaviors of different kinds. Maybe the agent, is able to generate and formulate a goal and generate a plan to achieve that goal and execute the plan. But for whatever reason, the goal still isn't true at the end of the plan. And so it just does that again, and then it does it again. It just keeps cycling. And so to break out of these cyclic behaviors is one of the big reasons I think metacognition is useful. And then there's a lot of different ways, or I'd say there's maybe 3 different ways right now that I'm thinking about metacognition that can change cognition. And one is maybe it's changing the parameter of an algorithm. Maybe it's changing the algorithm itself. So you're using a different type of planner. And then maybe it's changing the knowledge. And so this is where it could be strategy knowledge. It could be learning a new action model, things like that. So where would that happen? Well, if we're going to learn, so I talked about the kinds of things we would need to learn in Dungeon Crawlstone Soup. State transition models are probably mostly going to be used in this planning component. If we're learning strategy, maybe that means we're learning different goal choices. Maybe it means we're learning different action choices. There might be, I showed that difficult combat scenario before, and people said there's a lot of different kind of plans that you could take to execute this. Maybe just which action is best in a certain, this could be a type of strategy you learn. And then also, there might just be better situational awareness, and that would be in this module. So you might imagine the metacognitive loop is making changes to knowledge that affects these 3 different components. And so maybe by recognizing failures in these components or failures elsewhere, it can determine that. So with that, I'm going to talk about where we are with our API. So the goals of our API is really to make it easy for AI researchers to use this game as a test environment. And we also very much wanted to preserve the Dungeon Crawlstone Soup game engine, basically leave it untouched, just to keep a sense of kind of completeness and separation so that we're not somehow giving ourselves an advantage without even knowing it. And motivation, I think to push the field to use more complex domains as test beds. it's certainly useful to have simple domains, especially to isolate that one variable you're trying to test, or just measure a very specific effect from a new technique. That's still needed. Um, I think that I guess maybe it's just a feeling from my part that I think cognitive systems can shine in a lot of complex, interesting domains, and I want to see more. I want to try and make it easier for folks to be able to apply cognitive systems to these complex domains and have some fancy demos and shiny results and things like that. So features of the AI wrapper. One thing that we're committed to is multiple state representations. So this means that developing vector-based representations, right? Very similar to what NetHack did for, what Facebook did for NetHack, and also PDDL. Currently, we have a PDDL 2.2 model that's usable. It's still under development. We're still adding a little bit to it, but it works with a planner. And then, with PDDL 2.2, it does not have some of the other things. It doesn't have a lot of numeric aspects, and so we want to add those. But basically, we have a game object that makes it low effort to add new representations, such as other PDDL variants or other languages outside of PDDL. Recently in August, we published a workshop paper at a workshop in ICAPS, and with that, we released a high-level PDDL domain file. So it's currently a little over 2,100 lines, and it includes all the types of objects, monsters, spells, etc. And it currently works with the fast downward planner. The API is cross-platform. We've tested it and used it on all of these. And there's also just some quality of life features for using it in AI research. So real quick, this is how easy it is to create an agent. Basically, you import the API. You're going to extend the space agent class, and then you just have to override this get action function. So this is where you get the state of the world. And then this is where you return your actions. So here it's returning a random action, but you just change that. You call your planner, add another method, or call another class, etc. And then to run an agent is a similar amount of code. You're going to basically just import the connection information. You can set a lot of the details here, such as which game mode you're going to play, which sprint, or you can provide the seed here, and then you basically just have to pass your agent into this connection object to the game, and then you hit run. And so now I'm going to show a demo of the current planning agent we have. So this is a planning agent with some simple goal reasoning, and what you're going to see on the left here is I'm starting it in the terminal, and then it's running here. And one of the things you just saw is it exited out of a previous game. So that's a flag you can set, always start a new game when you start the API, and then it's controlling an agent. So the way this agent works is it kind of has three different goals. The first priority goal is if it sees a monster, attack it. The next goal is if it sees stairs to go down, it's going to take the stairs down and go to the next level. So it tries to descend as quickly as possible. And otherwise, it tries to explore. So it killed the monster. It's going to go down the stairs. And now it's on level 2. And it's exploring. And you can see on the left, it's printing out a little bit of debug information. And it has its own internal map representation. So the agent's currently exploring. It's found some stairs down. So it's going to navigate there. It's going to attack this goblin. Sometimes when there's monsters, it's going to go between, might isolate between them. It's killed both of them, but it's taking some damage to its health. It's right now it's not doing anything with items yet. We've been focusing more on the API development rather than agent development so far. So now it's encountering the snake. Let's see what happens. Okay, it killed the snake, it reached level 2. Still health is quite low. And Okay, found a null, and yep, it died. So the agent died, and the API is just going to start a new game. What you're seeing in the browser, so the agent's already started playing the game. What's happening in the browser is I'm just spectating, basically. So this is running even if I'm not looking at it. And the API has a feature where it'll just automatically start a new game. And you can also end a game after a certain number of actions, or after a certain, you can actually give the agent itself a function where if it returns true, it'll end the game for whatever reason it wants. So with that, it's going to make it easier to basically run experiments, etc. So, and the agent's playing, and it's going, and it's moving around, and yeah. Okay. So okay, so I kind of emphasized this a little bit before. We are providing both a vector-based and a PDL-based representation. So this is actually like little mini screenshots taken from the documentation that's describing basically the data structures you can get back for the vector state and the PDL state. Currently, these are available. These are kind of next up on the development agenda. These are available, and these are next up on the development agenda. And we also have the kind of background knowledge PDL file. And what you had just saw before that little demo, that was using the fast downward planner. So these are the type of experiments we want to be able to support. This is just, there's not much to take away here except the fact that we are comparing, a Q-learning reinforcement learning agent to a fast downward agent. And these are the kinds of experiments I want to do. Now, there's not a lot of context here given, but it turns out, you might look at this and be like, Q-learning agent is not exploring as many tiles as the fast downward agent is, but it turns out the fast downward agent is given more knowledge than the Q-learning agent. So it's not really the fairest comparison. So we want to.
Hey, Dustin, this is just your 5-minute warning.
Okay, thanks, Travia. I have full screen, so I can't see anything else. So not even my clock. So that's helpful. So basically, we want to be able to do more experiments where we can compare diverse agents using the API. So just a timeline of where we've been and where we're going. I first heard about this game in 2015. In 2018, when I was at the Research Laboratory with David Aha, started looking into building an API. In 2019, we released a workshop paper where we kind of analyzed the game, did a state space analysis. And then in 2020, Facebook released the NetHack learning environment, which is awesome. And it really lit a fire under me to try to keep moving, and it's good motivation. They did cite this paper, which was nice. And then earlier this year, I started to live stream the development on YouTube that I was doing. I think it was one of the things where it was a fun thing. I always wanted to try it, and it was during the pandemic, so I gave it a shot, and I've been continuing that. So we've currently had about 14 streams. I'm planning to put this talk up on the YouTube channel. So if you'd want, you can check that out. Especially one reason I have that there is just so if any grad students or any researchers want to use this, that's a place where they can give some insight into, how the API is being built and things like that. And then in August, we did a tutorial at ICAPS. So we had about 15 researchers download it and run it. So there's tutorial instruction pages. And we also had a paper in the workshop where we basically explain the API for both vector and symbolic state representations. So this is where we're at now. Near-term goals, add monster details to the API, finish the PDL API. I want to optimize terminal mode. So one thing right now is that when you run it, it takes between kind of 0.2 seconds and 0.2 to 0.5 seconds to execute an action, which is a little slow. In previous versions of the code, before we did some kind of major refactoring, we were getting it up to 500 to 1,000 actions per second. And that's really somewhere we would need to be to execute or to build reinforcement learning agents. So that's something we're going to work on in the near. These are all things we hope to accomplish in the next couple of months, and maybe eventually we'll get to agent development. So if you'd like to get started or check it out, we have GitHub and we also have documentation. The ICAPS tutorial video is online. There's also the documentation for it. I posted these slides in the Slack, so you should be able to just click these links. And then we have a Gitter. So if you're not familiar with this, this is a kind of a public chat room style thing that's linked to a Git repository. I saw that the Minecraft Malmo folks set one up for their API. So we've set one up for Dungeon Crawlstone Soup. So if you are using it,
yeah, maybe we should have like a couple of minutes for questions.
Okay, I'm sorry. This is my last slide. Just thank you to my collaborators.
Yep. So attendees, like if you have any questions, please feel free to post it on Slack. We have a separate page for a Dustin's invited talk, and let's see if we have any questions. So we have one question from Dr. David Eha. Given the complexity of DCSS, it seems worthwhile to define a sequence of challenges that are aligned with the requirements they place on intelligent agents. Has this been done?
So David, that's a good point. No, I don't think it's been done. I do think we could leverage the tutorials and sprints to so just getting an agent that could do the tutorials, that would have them learn different aspects of the game. Certainly the sprints, which are not procedurally generated and kind of fixed every time, those could certainly be an easier. They're also just smaller in size, so that might be easier, for example, to test action model learning or other things, because you would have less things happening at once when you're trying to learn what your action model is. So, but yeah, to answer your question, we haven't formally done that yet, but that's a great idea.
So I think we'll just ask one more question, and later you can maybe go into Slack and maybe answer some more questions. Sure. Yeah, so we have one question from Gagana B, and she asked, you talked about how it's over once you make a mistake, as the game doesn't offer second chances. How does AI handle these specific scenarios, given that it works mainly on approximations?
So I'm not sure exactly what you mean by approximations. I should say it's not necessarily a single mistake. Usually there's a couple mistakes that end up occurring, but if you make a couple mistakes in a row, that's kind of it. And one thing that's nice is because it's procedurally generated, you're not kind of memorizing what to do in every exact state. So basically your approach is going to have some generality to it because it's procedurally generated. You're just not going to get into that exact scenario every time. Yeah, if you're able to elaborate what you mean on approximations, yeah, that helped me.
Yeah, thanks, Dustin. It was a great
I'll check out the Slack and see if I can respond.
Yeah, sure. Thank you. And let's invite our first paper presenter. It's a goal reasoning model for autonomous underwater vehicles by Dr. Wilson and Dr. David Eha.
Okay, is my screen visible?
I'm sorry, no.
It's not, okay.
Yeah, it's not.
How about now?
Yes.
Perfect. Okay, thank you very much. Hi, everyone.